So really quickly, this is another lovely review song for the water cycle. If country is your genre of music, you might like this one a little bit better. I will be posting this one into the science notebook at the end of our day today. I'm going to be uploading these as we go along, so stay tuned. There is a cool water cycle song by Mr. Parr. He's a person who created a lot of our heat transfer songs. That is linked into your science agenda for today. Just in case you guys like music. Music helps me to remember things. So, especially since the water cycle is a quick little unit that we do it in less than a week. So since it's a quick little unit that we do, I try to put in a couple different types of songs so that you can find the one that you like the best and listen to it and try to memorize the lyrics so that you can remember the processes in order and the impact that they have. So first of all, again, the water we drink today is the same water that has existed since the world began. It is recycled over and over again in a process called the water cycle. So just like we recycle plastics and metals and that type of thing, we recycle, we reuse water. All right. So very quickly, without this one thing, it is the motor, it is the driving force behind the water cycle, then pretty much our water stays in its accumulation or collection spots. So what type of thing am I talking about? What is the motor that drives the water cycle, that starts the water cycle? Any hands? Nobody knows? What gets the water cycle moving? Without this, the water cycle stays where it is. Oh, yes, Mackenzie, would you like to say it?
The sun's energy.
Yes, thermal energy from the sun radiates down on oceans, lakes, rivers, streams, ponds, and it heats up that water and it begins to convert it from liquid water to water vapor. When those water molecules begin to bounce around really fast and they spread out and expand, they become gas and they become water vapor, which results in evaporation. Now, the sun's energy does not just affect the accumulation or the collection spots where we have our water, like in the lakes, rivers, streams, and oceans. There's also somewhere else that the sun's energy heats up and causes this organism to release water. What is this that I am referring to? Anybody? No hands? It happens at the same time as evaporation. These processes happen simultaneously, and we illustrated it on the board yesterday. Not yesterday, Monday. Samira, what is that process?
Evaporation?
No, it happens at the same time as evaporation, but the water does not come from accumulation. Like it doesn't come from lakes and rivers and streams and oceans. The water comes from a different organism. No, go ahead and mute yourself. I'm going to let one of your other classmates with their hands up try to answer. Yes, Genesis? What process happens at the same time as evaporation? You change your mind?
Transportation.
Yes, transpiration. It was our code word for Friday. Absolutely. Excellent job, Genesis. So yes, transpiration happens at the same time as evaporation. So let's go back and review these two processes before we clump in a couple other things. So first of all, we're just going to review everything. The water cycle is the journey water takes as it circulates from the land to the sky and back again. And this picture is in your science notebook, your digital science notebook. So it is the cycle that takes the water from the land to the sky and back again. The stages of the water cycle are evaporation and transpiration. They happen simultaneously. Evaporation happens from your different water sources like the ocean, lakes, rivers, streams, puddles. Transpiration happens from your plants. When the, please stop trying to guess the code word. The code word is not condensation, and it is not, I'm not having anybody guess the code word right now because I am not at that point in my lesson. When I ask you all to try to guess the code word, that's when I can start seeing those in the chat. But I would prefer that you not use the chat for that right now because it causes the chat to go up. So if someone actually has a legitimate question, I'm not going to see it. Okay. Sorry, I'm off of my soapbox now. All right. So today we're going to focus on these 3 stages of the water cycle, which is condensation, precipitation, and runoff. So just like we've said before, the sun is the energy source that drives the water cycle. It is the power. It is the motor. It runs the water cycle. Without the sun, the water cycle stays in its place. All right. Evaporation happens when the sun heats up a collection of water and turns it into vapor or steam, and it rises into the air. So remember, heat energy radiates from the sun, and it warms up the surface of water that has collected or accumulated. And it causes these water molecules to vibrate more rapidly, until they transfer from a liquid to a gas. They have a change, a state of matter change. They go from a liquid to a gas, water vapor, which is why we have evaporation. All right, so evaporation happens when the sun's energy warms up the surface of any accumulated water source and causes that water to change from a liquid to a gas, and the water rises as water vapor. And then, of course, transpiration happens at the same time as evaporation. We have the processes happening simultaneously here. Transpiration, the leaves are giving off moisture through the stomata, which is like the little pores that are on the leaves, like our skin have pores which we perspirate from. The stomata is the pores in the leaves, and they release the water from the leaf. And then that water evaporates. So that's called transpiration, which is evaporation from the leaves, from the moisture that comes out of the leaves of plants. This happens on your blades of grass. It happens on trees. It happens on flowers, anywhere you have a plant. Now, something cool that you guys can do, especially those of you who are struggling in science right now, maybe your grades are a little lower than you want them to be, I'm giving you an opportunity to do a little kind of observation activity on your own for some extra credit. So here you will see a picture of a Ziploc bag, and it is simply rubber banded. There's a rubber band there around this leaf, so that any of the water vapor that comes out of the leaf, out of the stomata of the leaf, is captured on the inside of the bag. Okay, so we're actually capturing transpiration as it happens. The water that's released will be collected on the inside of the bag. Now, I only want you to keep the bag on the plant for really just a day is all you need. But a full day, like if you put it on right after science class, keep it on until science class tomorrow so that you have enough time for the water to come out of the stomata, to evaporate in the sun's heat, and then condense on the bag. And then that way we can see what is happening there. take a picture and then you can email it to me, and then that's when I will give you credit on your lowest science grade. You can also explain to me what is happening in this picture. You guys know you push those 3 dots in the top and you can annotate on the picture. All right, so here what has happened is the water has come out of the stomata on the leaf, and then it can't go anywhere because the bag is stopping the water. So it would evaporate into the air, but since the bag is here, it kind of stops. So then it collects on the plastic bag. So then that's why you can see the condensation there. So that is proof that water is coming out of the leaf. All right, so just as water evaporates from collections of water, it can also evaporate off of the leaves of trees and plants. All right, so we are going to watch a video of the best scientist that I've ever known, Mr. Bill Nye the Science Guy. He's going to explain to us the process of condensation. But before we watch the video, we're going to read the definition here. Condensation is water vapor in the air gets cold and changes back into liquid water droplets in the air. This is how clouds are formed. Now this definition is missing something because liquid water vapor just condensing back into liquid water sorry, is not all you need to create a cloud. We also need one more thing. So I want you to pay close attention so that you can tell me, what did I forget in this definition here? All right, I'm going to zoom you guys in for Mr. Bill Nye, the Science Guy.
Bill Nye, the Science Guy. Hey, I'm in here. I'm in this giant freezer. Now, let's see what happens when I come outside where you are. See, the surface of my bubble of science turns cloudy. That's because water vapor, which was floating around in the air, sticks to the cold surface in little liquid water droplets. Now, this process, this effect, this thing that happens is called condensation. It's the same thing that happens to people who wear glasses when they come in after being outside on a cold day. It's where clouds come from. Where'd you guys go? Oh, very funny. Anyway, condensation is sort of the opposite of evaporation. Instead of liquid water gaining energy and becoming a vapor, water vapor loses energy and becomes a liquid. Little tiny droplets that stick to cold surfaces. It's a very important thing about condensation. Water vapor needs a place to stick in order for condensation to happen.
Look at the glass next time you drink your milk. Does it seem to sweat? Well, the glass isn't really sweating, of course, but it is wet. It's just the water vapor in the nearby air being condensed.
When clouds form, water vapor turns into tiny liquid water drops. But in order for that to happen, the water has to have some place to stick. It has to have something to stick to. So take a look at this. This is our big glass jug cloud apparatus of science. We're going to make a cloud in here. First, we'll add a little water. This will be the water that will form our cloud. Swirling it around a little. Now, using this pump, we'll pressurize the big glass jug. Then when I pull this rubber stopper off, the air in the jug will expand. And that's when a cloud should form. 3, 2, 1. See, nothing happened. That's because the water vapor didn't have anything to stick to. So what we're going to do is add some dust. Just a tiny amount of dust. And to make the dust, we'll use the smoke from these 2 matches. That's all the dust we need to form a cloud. Now watch. We'll pressurize it again. When I pull it off, the air in the jug expands. And when it expands, it cools off. The same thing happens to air masses when they get blown around by the wind and pushed up high into the sky. 3, 2, 1. See? It's a cloud. It's the water cycle. It's science.
All right, guys. So what is the one thing that this definition is missing here? It says water vapor in the air gets cold and changes back into liquid water droplets in the air. This is how clouds are formed. What else is needed to create a cloud? What else do we need to create a cloud? We need water vapor that has cooled down. And what else, Samira?
Evaporation.
No, condensation is the exact opposite of evaporation. So what do we need when, remember, when water vapor begins to cool down?
It needs something to stick to.
Yes, it needs something to stick to. Just like the water droplets on my cup here, they have my cup to stick to. These water droplets are not coming from inside of my cup. The water droplets that you see here on my cup, they have condensed and are actually even starting to precipitate there. You can see that water droplet's getting ready to fall and precipitate. What happens is the water vapor that's in the air around me in my classroom sticks to my cold cup, which causes condensation on the outside of my cup. And then once those water droplets continue to collect, what will happen is they will run down the side of my cup as precipitation. So yes, Samara, you're exactly correct. So clouds need something to stick to. So what happens is water vapor molecules evaporate. They begin to bounce around all crazy like gas molecules do, and they start floating up in the air as water vapor molecules, super tiny gas particles that we can't even see. Looking around my room, there's tons of water vapor molecules, which are evident on my cup because they have all collected there. But there's thousands of water vapor molecules in the air around me, but they're gas, so we can't see them. But what happens is they rise higher and higher into the atmosphere. Our atmosphere gets colder, colder and colder the higher you go away from Earth's surface until you get to the different layers, but we'll talk about that when we get to weather. But in the troposphere, which is where weather happens, the higher you go, the colder the atmosphere gets. So as the molecules begin to get higher and higher, they get colder and colder, so they clump together. Now, they've got to have something to stick to in order to be visible like these clouds are here. So when they start to clump together, to huddle together to conserve some of their heat energy, they stick to dust particles, which forms the clouds that you guys can see. That's why you can see clouds. And these actually become water droplets and dust compose clouds. So when you have clouds, you no longer have water vapor, you have teeny tiny water droplets that have bonded with dust, and they clump together to form a cloud. And then once the cloud gets so heavy, you can see this cloud here is a little gray. Once it gets so heavy that it cannot hold all that water anymore, you begin to have precipitation. So precipitation is a form of water that falls to the Earth's surface when so much water has condensed in that cloud that the drops become heavier than the surrounding air. So the different types of precipitation we can have are rain, hail, snow, and sleet. With these two types of precipitation here, snow and sleet, the temperature has to be less than 32 degrees. Less than 32 degrees Fahrenheit. Now, sometimes what will happen is you'll have snow because the atmosphere is less than 32 degrees way up high in the atmosphere, so the snow begins to fall. But then, here on the surface of the Earth, it might not be less than 32 degrees, so as soon as it lands, it melts. But in order to see snow and sleet, these are our winter precipitations. and the temperature has to be less than 32 degrees Fahrenheit. We'll talk about hail a little bit when we start talking about the way different clouds are formed and what causes hail to happen. But normally when you have like really severe thunderstorms, that's when you will see hail, because hail is big ice chunks, and you can see them any time of the year. You can see them in the winter, you can see them in the fall, you can see them in the summer, but a certain type of cloud has to be present in order to see this type of precipitation. And then rain, of course, especially here on eastern North Carolina, that's the type of rain, that's the type of precipitation that we see the most. Now, Laylan, I see your hand is raised, so you may go ahead and ask your question or share your statement.
So this is actually about hail. So one day we were on our porch and we saw like this big chunk of ice fall out the sky, and we were like, what is that? And my mom saw it and she said, it's hail. And I said, what is that? She said, it's little ice pieces that fall out the sky. And then more kept falling down, and my mom's windshield of her front car broke, so she had to get a new one.
Yes, and that is very common, especially in severe thunderstorms like that, because hail can be as small as, like, I don't know, something tiny, like a grain of sand. No, bigger than a grain of sand. But it could be super tiny, but it can grow all the way to the size of a baseball. And we'll look at some different types or different sizes of hail in our presentation for tomorrow. But yes, it's definitely possible and probable to get dents in your car, maybe a busted windshield. Hail could be very dangerous, but it's also indicative that a very dangerous storm is around as well. Yes, Jamari.
What's sleet?
Sleet is ice. And sleet and freezing rain are very similar. And we'll talk about this when we get to weather as well, because we'll talk about it as it falls through the atmosphere. Sleet and freezing rain, one of them is water before they're ice. The other one is ice before it melts and then it turns back to ice. So we'll talk about that more as we get into our weather unit. But this is a type of wintry precipitation. It's ice. And lastly, Genesis.
So it's raining like badly when I was putting up groceries at my mom. It was like wind and it was like windy, and I actually fell because the wind blew me and it was raining badly.
Oh my goodness. All right, so after we have some precipitation, the water will flow to a collection point. The force of gravity pulls water down. We don't really have that as much here in eastern North Carolina, but the further west you go in North Carolina, you'll see more mountains and hills and valleys. So it's definitely prominent across the state, but here in eastern North Carolina, we've got pretty flat land. Which means we're pretty close to the water table, we're pretty close to the oceans. So a lot of our precipitation will actually fall into the ocean. Some of you may have big ditches out like at the edge of your front yard before you get to the road. And when we have really big thunderstorms, you might see those ditches fill all the way up to the top, maybe even start coming over into your front yard. That is an example of runoff and precipitation. So what happens is usually your yard is kind of at a slant until it gets to that ditch, so that all the water will run off and into that ditch, so that the water doesn't accumulate around your house and cause it to flood. So all of your houses and neighborhoods have usually been designed so that the runoff of the water will run into the ditches instead of around your house to keep your house from flooding. And then lastly, I will be giving you guys a quick little quiz tomorrow. It's not for a grade, just for participation, just to see where your understanding is. But water can collect in many different places, but the ones that I want you to be familiar with are oceans, lakes, icebergs, puddles, rivers, and streams. Okay, so if you want to take a screenshot of that And remind yourself of that before science starts tomorrow, because we are going to have a little competition in recapping everything that I've talked about, and especially this slide at the start of class tomorrow. So this concludes my lesson. Code word for today is water. I think Jacaden had already figured that one out. But this is what your assignment looks like. Again, you'll have 3 attempts. If for some reason you spell it wrong the first time, code word is there. And then the link to that other water song is in our agenda for science. If you don't have any questions, you are free to go. But if you would like to stay and chat or ask any questions, I'll be here. Bye.